The laser disc, the CD, compact disc, is a digital media device that uses laser technology. The laser, light amplification by simulated emission of radiation, because it is coherent light, forms concentrated rays, can be nicely focused and amplified. The higher the frequency of the light, the better the focus. There are several types of CDs. The first CDs, digital audio CDs, made by Sony and Philips in 1982, stored only audio material. This standard was recorded in the Red Book. The standard CD-ROMs specified in the later Standard Book, the Yellow Book, store not only audio, but also other data. CD is store interactive data according to a standard defined in the Green Book. Kodak photo CDs contain digitized negatives of photos in a specific format. There are machines that project photos on a CD onto a screen. Data is recorded on CDR or CD-ROM. Write once read many CDs, not in production, but in writing with the help of CD writers. This standard is included in Panasonic's Orange Book. The entire contents of CDRWs, rewritable CDs, can be erased and replaced with new data. This is accomplished with a more modifiable crystal structure surface and a weaker writing laser beam. Above the standards for the various types of CDs is the international standard ISO 9660, which contains data structures, data recording methods, encoding systems, and the structure of tables of contents and directories. Most CDs and CD readers writers are made to this standard. The CD is a clear plastic disc 12 cm, 8 cm for an 18-minute mini CD, with one surface covered with a reflective layer of aluminum. This is coated with a 2-micron thick protective layer to prevent oxidation and other contaminants. The CD stores the data in a spiral, moving from the inside out. The distance between the spirals is very small, only 1.6 microns. The data is located in sectors, blocks, through which the CD reader accesses the recorded data. One sector is 2048 bytes for Mode 1 coding system, 2352 bytes for Mode 2 coding system, storing error detection codes and error correction codes. In this case, there is a 288-byte error correction and 16-byte information code in each block. For a CD of 74 minutes of audio or Mode 1 encoding system, without error checking code, 650 MB, for Mode 2 encoding system approx. 550 MB of other data can be stored. More recently, higher density, 80-minute, approximately 700 MB CDs have been produced, but these are not yet standardized. The CD reader continuously changes its speed on the flight to read the data at the same speed on the inside and outside of the disc, about 200 RPM on the outside of the disc and about 530 RPM on the inside of the disc. The standard states that the CD reader can read 75 sectors per second during playback. CD readers have a data transfer rate of 150 kbps for single CD readers, but the latest drives are 40 to 52 times that. Although they are much faster than hard drives, their access time is even slower, about 140 milliseconds, as they do not handle a fixed surface. If the CD is defective or of poor quality, the CD reader will try to read the data at a slower speed. But if you can't scan at even a single speed, it will stop with a media error message. Error correction tools and programs can be used to correct errors unless the surface is damaged in the path of the spiral band. When a disk is read, the data is first placed in the buffer, memory area, and processed by the PC. The buffer is 64 KB as standard, but newer drives have up to 2 MB of buffer. You can also convert the capacity of a CD from minutes to bytes, sector size times 75 sectors second times 60 seconds minute times CD capacity in minutes. For example, the capacity of a 74-minute CD in bytes, calculated with Mode 1 encoding, 2048 times 75 times 60 times 74 equals 681,984,000 bytes, e650 MB. There are also internal and external CD readers. Previously used external CD readers communicate via the parallel port. Older CD readers are connected to the computer via an older control card for older models and their own special control program via ID interface, a TOPI control program, or SCSI card, SCSI control program, for newer models, or the operating system CD driver. ID-coupled CD drives, like hard disks, must be configured to operate as a master or slave. The NRZI method is used to record data on CDs, as it is used to record hard disks and magnetic disks, i.e. it has a binary value of 1 if the signal is turned to the opposite level. This signal is read by the reading head and then formed into interpretable signals, modulated according to the EFM method. It stores binary values in the form of small pits and intact surfaces. There are two practical ways to record data: production and CD burning. In the production, the data tested on the test plate is laser burned onto a glass master plate. If the level of the scan signal is reversed, the red value has changed from binary 0 to 1 or from 1 to 0, then you either finish burning the pits or start it. The master plate is pressed onto a motherboard. Since the pits and intact surfaces thus obtained are located upside down as on the master plate, another copy is made. This father plate is already in its original working condition. Commercial plastic discs are made from this sub-disc by CD writing. CD burning is done using a CD burner. The CD burner's more powerful burner laser in the spiral band either burns pits, destroys the crystalline surface, or leaves an intact surface, depending on whether the scanned digital value has changed. When a CD is read by a CD reader, a weaker laser beam focuses on the track and is reflected from the aluminum layer. From the intact surface, the light is projected into the sensor with a small angle of refraction, so it gets a value of 1. Due to the large refraction caused by the pits, the light deviates, the scanned signal is weak, so it gets a value of 0. There are two types of CD burning operations. Single session, data is written to a CD at once, and multi-session, data is written multiple times in several consecutive datasets. The first CD writers were not able to write in multi-session, but the newer ones are already capable of it. When writing in multi-session, writing each session, dataset, takes up slightly more space than the amount of data to write. Writing disks at different speeds is determined not only by the speed of the CD burner, but also by the writability, type and quality of the CDs. You can even create a CD in a bootable format, so you don't even need a hard drive to perform simpler tasks. An improved version of the CD is the DVD, digital video disc, which has a much higher bandwidth and can be double-sided, double-layered. There are two types. The data is burned to the read-only DVD-ROM at the factory. Its standards were recorded in 1996 in Book A. You can record data on a readable and writable DVD-RAM with a DVD burner. Its standards are contained in the not yet finalized e-book. 4.7 GB for a single-sided, single-layer DVD-ROM and approx. Storage 17 GB of data. You can write 2.6 GB of data on one side of a DVD-RAM. You need a DVD reader to read them. Read information from the CD interface. Left side. Scanning of the laser beam. Right side. Light reflected from the pits. CD signal recording. Top. Original sign. Central. Incineration. Bottom. NRZI recording mode.